Okay, so I figured I'd post or make a video of some updates that I've made to my Kyosho Lazer ZX-S Evolution. Um, I made a few changes since the last time I ran this at Vintage Off-Road Nationals, and generally speaking, for the past couple of years, I've been trying to develop this car and make it fast and reliable. And the fast part is no problem. This car is plenty quick, but I've run into a number of different issues with the belt skipping, and I've been trying to address that as best as I can. So I'll go over that and a couple of other things that I found over time. So we'll start with just some of the simpler things. For the wheels here, you can see I have Yokomo wheels now on the car. These are the Yokomo dish wheels that you would put on the 94 or 95 YZ10. To make this work with the modern Kyosho CVAs, I have JC Racing Products Kyosho to Yokomo wheel adapters. Now these are rear wheel adapters for both the front and rear, so I had to basically order two sets, because when you order those wheel adapters you get an Ultima front and rear set. So I asked the guy if he could just send me two rear pairs, and he said okay. So anyway, that's how this works. Now to get the offsets right, for both the front and the rear, you're going to need the wheel axle with the three little rings on it, the widest rear axle that Kyosho has for the modern CVAs. And I think especially on the rear, what you're going to want to do is put wheel space, space it such that on the outside of the outer bearing, you have a wheel spacer there to push this wheel hub out. Okay, if you don't do that, then the rear is going to be too narrow. And then with the front, I actually don't quite remember. I think the spacers are on the inside, but nonetheless, there's a way to set these spacers up just right so you get the correct width with these wheel hubs. Okay, so that covers that. Another little thing is with the front lower gearbox here. As you may know from the previous build videos I did for this project, I have all of the molded parts drawn up in CAD so I can get 3D printed spare parts for this car. And I've been running the 3D printed parts on this so that I can preserve the original parts. Now the material that I tend to use, material of choice, is PA11. It's kind of like PA12, but it's much, much stronger and more flexible. PA12 is kind of like the cheap piece of crap material that most people use when they make their 3D printed parts and sell them on eBay. But PA11 is a much better material. It's a little more expensive, but it's worth it. And what I found, though, even with the PA11 part, that on the front gearbox, maybe it's a little hard to see here because this particular piece is black, but in order to get this belt to not skip, it has to be kind of tense, and that's going to pull back on the diff, and it's going to put pressure on the lower gearbox, and that will end up cracking along a certain point in the lower gearbox. And I see it on both the left and right lower halves. It cracked along the same spot, so that part is going to be under a fair amount of stress. So you're going to want to order a couple of sets of those lower gearbox pieces if you get them 3D printed, and make sure you do it in PA11. PA12, which is the more sort of the cheaper plastic, that can also work. That's what I'm running on this right now while I'm waiting on some extra PA11 parts to come in. I have tried some other materials. There's I forget the exact name, but it's some kind of like strong plastic material that's very stiff, and when you print it, it feels very tough. And I tried that. I mounted it in here, and I suppose it's tough but brittle because it ended up cracking within just a few days. I looked at the car again, and I saw that the part was cracked. So you want something a bit flexible here for these lower halves. And as usual, you're going to have to, tap the holes out and everything. And of course, the other thing is make sure on the left, this would be the left side of the chassis, the left lower gearbox, you have to shave out a little bit of the inside of the gearbox so that the diff itself doesn't rub up against that part of the plastic. You'll know when you mount it. Basically, the bottom part of this lower half mates to the kick-up plate, and there's a little sort of flange or thing that comes out, and it's part of the original part, but that can rub up against the diff here, and that'll cause a lot of friction. So you just got to grind that out a little bit just to make some clearance, and that'll spin just fine. Okay. As for the actual belt itself, I'm using excuse me. Tough Racing doesn't make belts for the ZX-S Evo, so I use poly belt for most of my belts, like for my YZ10 and for the ZX-S, for instance. Poly belts, they're based in the United States, so I can get them shipped to me pretty quickly. Now the thing is, their belts, just like most other timing belts, have a thicker spine. And the original Kyosho part for this has a thinner spine, which is what allows you to use the roller bearing in its original location. If you have a thicker spine, then the exact spot where this hole is drilled for the roller bearing to come across is too low. And so you won't actually be able to fit the belt under the roller bearing with a thick belt spine. So that's one reason why I've been having trouble trying to figure out how to get the right belt tension and not have the belt skip. In the past, I had a part here where I sort of jerry-rigged a tensioner that would sort of, I could sort of pull it down and push down on the belt to give me some tension. But then as the car goes forward and the belt moves forward, it's actually going to push that tensioner up. So it would work for like 30 seconds, and then I'd hear it skipping. Okay. So what I ended up settling on is what you see here. So this is a 3M 546 front belt, and the rear belt, by the way, just for reference, is a 174 length belt, 3M 174. So for the front belt here, what I did is put a roller bearing on this hole here. Normally you'd have a cross brace here, kind of like this red piece here. It would go across here to hold these two halves of the gearbox. But instead, on this hole here, I just mounted basically a long screw with some bearings. I believe these are 3x6 bearings. And that's just my roller bearing. It just happens to fit perfectly, and it's positioned close enough to the belt so that this belt can't come up. This should prevent it from skipping, and it's fixed in place, so that should be fine. And I'm not so worried about like any flex or anything between the left and right halves of the gearbox, because you're supposed to have normally in the build, I think 1, 2, 3 cross braces to hold the two halves together. But there's so much stuff going on here with how it's built. You can take one of these out and it's okay. Also, remember that each of these halves is also mated to the rear shock tower. So there's plenty of stuff to brace this in place. It's not going to flex around too much. So you can play around with these things. So I put a roller bearing here. And then for the rear belt, kind of the same deal. I don't have, I think those are, oh, it's really hard to see. But where the heck is it? Yeah, it's in here. As the belt comes down under the rear diff, it has to come back up like this to go up and around the motor. So there's a roller bearing there that I use. And I think that's the original location for the roller bearing, if I remember correctly. Oh yeah, okay, you can kind of see it here. Where this screw is right here. Okay, and then maybe if I just go out into the light. Oh yeah, maybe that's a little better. You can see that little silver looking thing right there. So across there, it's basically a long screw that braces both sides. But within that brace, I have roller bearings on the right hand side for that belt to come up and around. You see how that belt's wrapping around right there on the bottom? So that holds the rear belt in place and seems to do a good job. So hopefully next time around, I won't have any issues there. The other thing that I wanted to address on this is the steering geometry. So the last time I ran it at Vintage Off-Road Nationals in, what was it, last September, it drove great. Like the suspension setup was perfectly fine. It steered fine. Like I didn't notice any specific problems. But when I had a big enough problem with the drivetrain that I couldn't fix it in time, and I had to get out my X-Factory X5 as my backup car and run that, I found that car to have a lot more steering. And that's just sort of the intrinsic advantage that I thought that the double X4 and X5, because they use the same parts that they have, is that their steering geometry gives you a lot more low-speed steering into really tight corners. And so I figured, well, is there a way that I can mess around with the steering geometry on this to give me the same thing. And it turns out that the short answer is yes, right? It all just comes down to how the steering hubs, how tunable the steering hubs are, and how tunable your steering rack is. So this steering rack is not the stock steering rack for the ZX-S. This is actually an Exotech ZX6 steering rack, which allows me to mount the inner ball stud this way. Right, normally on the Lazers, the ball stud mounts vertically. Here it mounts horizontally. So I can move this in and out to adjust Ackerman. And on the steering knuckles here, these are Jazz Rider aluminum knuckles for the Optima, I think. But they fit on the Laser. They're interchangeable parts. So what's important about those steering knuckles is that you have two holes. In the past, I was using this hole in the back here. And on the inner ball stud, I had this pushed back a little bit. But that was actually reducing Ackerman. Generally, if you want really aggressive steering on tight corners, you want more Ackerman. So that forces you to push this forward and push this backward. So I tried that, and it wasn't quite doing it. So then you just have to actually look at the steering linkages themselves and what happens at full throw. Right, so at full throw, you want the inner link to basically to pull the knuckle as far in as possible. Okay, that'll give you the most aggressive Ackerman. So that actually required me to move this ball stud to the inside. So I moved the ball stud to the inside. Okay, and then on the inner ball stud here, I actually use a low mount ball stud, a Kyosho low mount ball stud, and that allows me to move this forward just a little bit. This actually gives me really nice low speed steering, so I can do really sharp, hairpins. So the steering geometry appears to be all set. The belts should be all set, front and rear with the appropriate belt length, even though the spine is thicker, and affixed to the front belt tension, so that's all set. The shocks, I did, I haven't changed anything in the rear. The fronts, I did think about going softer on the front springs. Right now I'm running associated gray front springs. I think I previously had Losi black, which is a higher rate. These I think are a 3.4 rate. Is that right? Or maybe 3.6. And the Losi black I think is like a 3.8 or a 4.0. So, one or the other. But yeah, that's kind of it. Just a few little updates to this car. I will be bringing this to the Vintage Off-Road Nationals this fall. Hope this will be like the fourth time or something that I've been trying to get a good weekend in with this car. And I'll make a video in due course about the full fleet that I'll be bringing and what other special projects I have coming that I'll also bring with me. But this should do it. So hopefully that's the last of the build series for this car. All right, that's it for now. Thanks for watching.